In this lecture, we will discuss how to solve a problem related to ideal gas equation. So whenever you have a problem related to ideal gas equation, you have to read the problem and you have to tabulate the information. And what are the information that is given generally? You will be given pressure, you will given volume, you may be given temperature, and you might be given number of moles. So you have to tabulate these values. What is the value of pressure, what is the value of volume, corresponding temperature and number of moles. Generally pressure in short, it is written by capital P, volume is written by capital V, temperature is capital T, and number of moles is a small n. Apart from these four variables, if any other information is given, that should also be tabulated here. So any other information should also be tabulated. Now once you have this information, these four variables and any other information, you have to convert into consistent unit. Like pressure, we need pressure in atmospheric pressure. So if pressure is given in torr, we have to divide by 760 to convert into atmospheric pressure. Similarly volume is given in liter. If volume is given in milliliter, then we have to divide by 1000 to convert this into liter. Now temperature, so we need temperature in Kelvin. Generally this is given in degree centigrade, then we have to add 273 to convert into Kelvin. Now number of moles, sometime moles is given directly, but sometime moles is given indirectly, that is might be mass may be given. So if mass is given, then you have to divide by molecular weight to convert into number of moles, and number of moles is n. So you have been given sometime mass, then you have to divide by molecular weight to get the number of moles. Once you have these variables in consistent unit, you have to solve for the unknown. Let us say if I have ideal gas equation PV is equals to nRT, and if I need pressure, so we have to solve for pressure. Pressure is nothing but nRT by V. If I want to solve for volume, I have to have nRT this divided by P. Or if I want to solve for number of moles, so I will have PV by RT. So you see this RT goes this side, so PV by RT. Or if I want to solve for temperature, I will have PV by NR. So this is the, we have to basically solve for unknown. So whatever the unknown, either pressure, volume, temperature or number of moles, we have to solve for the unknown, and then we can plug the value of nRTV or nRTP to solve for volume, solve for pressure, correspondingly number of moles and temperature. So this is T. Another important point we have, that is it is always advisable to use dimensional analysis in this kind of problem. Let us say what is the dimension of R. So if I ask you what is the dimension of gas constant R, and this is easy to define. We have PV is equals to nRT, so we will have R is equals to PV divided by N into T. So dimension of R can be found. Pressure is atmospheric pressure, volume is in liter, and this is mole, and this is Kelvin. So dimension of R is atmospheric pressure into liter into mole minus 1 into Kelvin minus 1. So now let us see what is the meaning of using dimensional analysis. So let us say if I want to solve for pressure, that is nRT by V. So if I want to solve for pressure, what we will do is we will write number of moles RT and V, all are with units. Let us say I have a question in which N is equals to 1 mole and T is equals to 273 Kelvin, and let us say volume is 22.4 liter, and we have to solve for pressure. So what we will do, we will write pressure is equals to N is 1, and then we also write what is the unit. So 1 mole multiplied by R is 0.082, and we have to also write unit, that is atmospheric pressure into liter, and this divided by mole into Kelvin. Then we have to write temperature. Temperature is 273 Kelvin. So we have to write 273, and we have to also write unit. Unit is Kelvin. Now bottom we have volume. Volume is 22.4 liter. So this volume is 22.4 liter. So now you see what is the advantage of carrying out dimension. Now mole goes, Kelvin goes, and this liter goes. So finally we have a dimension of atmospheric pressure, that is 0.082 multiplied by 273, and this divided by 22.4, and this dimension is atmospheric pressure. It should be, because pressure should be in atmospheric pressure. So dimension here we have is atmospheric pressure. So we can calculate for pressure. So I have 0.082, this multiplied by 273, and this divided by 22.4. So this is around 1 atmospheric pressure, 0.9, and so this is 1 atmospheric pressure. And this is obvious, everybody knows at 1 atmospheric pressure volume is for 1 mole of gas, and 273 degree temperature volume is 22.4 liters. So everybody knows at STP, that is a standard temperature and pressure, temperature is 273 Kelvin, pressure is 1 atmospheric pressure. We have for 1 mole of gas, volume is 22.4 liter. Let us apply whatever we have learned here. So we have a problem here, example. So read the example first. So we have to find weight of neon gas. And let us say what is the information that is given. So you have been given temperature and pressure. Temperature is given, this is 35 degrees centigrade, and this we have to convert in Kelvin. So 273 plus 35, and now this value is in Kelvin. Pressure is given in torr, that is 1.78 torr. And we have to convert this torr in atmospheric pressure. So 1.78, this divided by 760, and this value is 9 atmospheric pressure. And what are the other information given? Volume is not directly given, but volume is given in terms of another parameter. So we have a tube of length 5.5 meter, and the diameter of tube is 2.5 centimeter. So diameter is given 2.5 centimeter. So let us calculate volume. So volume is given by this cylindrical shape. So volume is pi r square h, and pi is 22 by 7, and radius we will have, that is 2.5 centimeter is the diameter. So 2.5 divided by 2, and height we have 5 meter, but we have to convert it to centimeter because this is centimeter square, and we have to convert this in centimeter, so 500 centimeter. So final unit volume for will we have in centimeter cube. So let us calculate this value. 22 by 7, or let us first multiply 22 into 2.5 a whole square, that is 6.25 multiplied 500, and this divided by 7 into 4, 2 square becomes 4. So this value comes out to be 2455. This is 2455. Now this is centimeter cube, that is milliliter, so we have volume in liter, so we can convert volume in liter, that is 2.455 liter. So now I know the volume, we know the pressure, we know the temperature, so we can convert for number of moles. So we have to write PV is equals to nRT. So from here number of moles is PV by RT. Let us put this value with dimension. N is equals to, pressure is given 1.78 by 760, and this is in atmospheric pressure. Volume is 2.455. This is in liter, and R is 0.082, and for R we have unit here, that is liter into atmospheric pressure mole minus 1 Kelvin minus 1. So liter into atmospheric pressure and mole minus 1 into Kelvin minus 1. So mole and Kelvin will go on the top. So we have written P, we have written V, we have written R, and we have to write temperature. So temperature is 273 plus 35. So let us try to solve. So we have liter here, liter goes, Kelvin, so this is in Kelvin, so Kelvin also goes, atmospheric pressure goes, so we will have N is equals to 1.78 into 2.455, this divided by 760 into 0.082, and this multiplied by 273 plus 35, so this is 5 plus 3 8, and this is 308 Kelvin. So this is, now you see final we will have mole, unit for this is mole. Now calculate this value, so we will have 1.78 into 2.455 and this divided by 760 into 0.082 multiplied by 308. So let us say we have very small value, that is 0.002, that is 2.27 into 10 to the power minus 4. So we will have 2.27 into 10 to the power minus 4 mole. Now once I know the mole of helium, so this is the mole of neon, so this is mole of neon, so we can calculate weight, and weight of neon is nothing but we have to multiply this by molecular weight, and molecular weight is 20. So weight of neon, this is 2.27 10 to the power minus 4 into 2, so this is basically a mole. Okay, now this is into 20, and now this value will come into gram. So let us see what we'll have. We will have 2.27 into 20 into 10 to the power minus 4 gram. So 2.27 into 20, so this is 45.4, that is 4.54 into 10 to the power minus 3 gram, or we can write in milligram, so this is around 4.54 milligram. So this neon tube neon tube contains only very small amount of neon, and that is 4.54 milligrams. So we have to find how many grams of neons are in the sign. So that is, if I ask in gram, that is 4.54 into 10 to the power minus 3 grams. So neon in sign is 4.54 into 10 to the power minus 3 gram.